Hello, this is Russell coming to you from the Tate Geological Museum at Casper College, and today I'm going to address a question that I got from a visitor. The visitor was looking at our skeleton of D, the mammoth, and he was a little confused by the bones of the forelimb. He noticed that this bone crosses over that bone, so they make an almost X shape in front of the animal. And he said, that's kind of weird. Why is it that way? Is it like that in other animals? This is a very good question, actually. And like many other questions in paleontology or biology for that matter, it only makes sense if you take into account the animal's evolutionary history. So first of all, what are we looking at here? Well, this is the humerus, the upper arm bone of the mammoth. And then this bone here is called the radius, and it runs from the elbow to the base of the thumb, the innermost digit on the animal's hand or forefoot. And then the other bone behind it, that is the ulna. So the ulna goes from the condyle there and goes to the outer portion of the hand like that, making that cross shape. So why is it like that? Well, if you want to understand the arrangement of these bones, you have to go back to their origin, and it goes all the way back to the lobe-fin fishes of the Devonian period. So at that time, there were not yet any land animals, but there was a either very, very fish-like tetrapod or a very, very tetrapod-like fish called Tiktaalik. Neil Shubin calls it the fishapod because it is very perfectly transitional between those two great groups. Here's the fin of Tiktaalik, and here are the bones that go inside of the fleshy lobe at the base of that fin, giving the lobe-fin fishes their name. And homologs with the bones in tetrapod limbs have been identified. The one closest to the body that articulates with the shoulder girdle is the bone that would later on become the humerus in land tetrapods. The blue bone that you see here is the ulna, and then this one is the radius. So this fin is in the position with the radius leading. So how do we get from that to that? Well, a good way to understand that process is to reenact the whole process yourself. So to start with, get down on the floor with your arms on the floor, sticking out on either side. That is the position that the fins would be in an early tetrapod like Tiktaalik. The thumb is forward, and the radius is in the leading edge of the limb. Here's a human arm. So this is the humerus up here. Here is the hand. There's the ulna, and there's the radius. So I was just in this position with the radius in the leading edge of that limb. All right, so after you're done with this position, do a push-up. And when you do a push-up, now you are a tetrapod. The earliest tetrapods walked like this, with the limbs sprawling out to the sides, like salamanders. So in this position, we've got the humerus coming out from the shoulder horizontally, and then we've got the radius, once again, in the lead, and the ulna behind. So this joint here is going to be in front. Well, this is all well and good, except that many tetrapods, including horses and cattle and mammoths, have found it advantageous to walk with the limbs held straight down underneath the body, to lift the body high up off the ground. Nobody knows exactly why. It might be that this helps them breathe and walk at the same time. But for whatever reason, what you need to do if you're going to evolve that upright, erect stance is swivel the shoulder so that the humerus is vertical down underneath your body. Well, if you do that, you end up with the limb like this. And then you can straighten out the elbow, but now you see a problem. You can't walk this way. If you're going to walk, you need to be able to flex the elbow forward and back, rather than simply folding your limbs up underneath your body. So, in order to do that, they took the humerus and twisted it like that. And now you've got the limb capable of flexing in this plane to enable walking with the limbs in an upright position. Here we've got the radius still attached to that original condyle and the ulna there, but since the thumb has been moved to the inside of the limb of the manus, then that means it's taken the distal end of the radius in with it and pulled it across the ulna, and that results in the crossed bones that confused our museum visitor.